Welcome, everyone. It's great to see some of my former students in the audience, at least one, but I'd like to, see if there's more. Now, I know that Liz said that if you're hungry for AI, you're here, but it looks like a lot of people are hungry for actual food, which is, still for the next maybe 10 years, we'll eat food and then we'll all turn into robots. But for those of you who missed what's going on here, so this is the plan. So this is a session to highlight Berkeley Executive Education, as well as for me to talk a little bit about, share random thoughts about what's going on in AI. And since one of these programs that Liz will talk about was inspired by customizing our AI class to a financial services organization, the topic will be AI in financial services. So that's the agenda for today, and as Liz mentioned, I have a background in both computer science and marketing, and for a long time I was just teaching marketing classes, technology-relevant marketing classes like social media marketing, digital marketing, but now everybody wants to learn about AI. Now, it actually helps that I'm a marketing professor because, just to be clear what's going on in the first half of the year, this is a sales pitch. We want you to learn about Berkeley ExecEd because we think we can provide a lot of value to your colleagues, your organizations, and whatnot. Anyway, so let's go back to where we were and talk a little bit about the AI class. So this is one of the motivating slides that I used to actually motivate myself when we designed this AI class. So this is the person who came up with the term artificial intelligence. And basically what he pointed out that once it works, nobody calls it AI, right? Like when you get your phone and then you do this and it unlocks. Well, it doesn't, but when it does unlock, then that's AI, right? Nobody thinks of that as kind of magical AI. Or when you write a text and it comes up with like funky words as the next suggestion, that is AI as well, right? There's so much AI. All the cameras. I mean, from the marketing perspective, they have I only have like 2 of these bubbles here, but like more consumer-oriented firms like iPhone, they would have like 3, 4, 5 bubbles. But other than that, there's a lot of AI in the software of how the picture is taken. So this is kind of what we're trying to explain to people that the magic factor is essentially the delineation. Where it becomes magic is where you don't understand it. So we try to push that out and demystify what AI is about. Just to highlight the difficulties of terminology, this is my favorite description of what's the difference between AI and ML. This is 5 or 6 years old now, and I think it's going to be true forever. Now, for clarity, we are only doing AI today. Unless you really want to get into that Python. Oh, I'm mistaken. There will be some Python. So a little bit of machine learning today. But the terminology is like so amazing. So I think if a random person comes up to you and they tell you that they are doing AI, the way I would interpret that is that I'm doing something with a computer. And this year, if they tell you I'm doing Gen AI, pretty much the same thing, right? If you can get funding if and only if you do Gen AI. Solution is tell everybody that you're doing Gen AI. But again, what we try to do in this course is clarify the terminology and not so much as in dogmatically tell people what they should mean by something, but be aware of the fact that everybody has a different understanding of what these terms are. So this is our course overview, and I should mention that one of the big advantages of this course is that we have a multitude of faculty from very different backgrounds. So there's me with this weird combination of backgrounds. So we have someone from industry who worked at Google on the Boston Dynamics robots. So he's currently an investor in AI startups. And then we have Peter Abil. He's the famous one out of the 4 of us. He does 5 of us. He does robotics at the engineering department, EECS. So it's a great combination. And we also have someone from organizational behavior. The name might sound familiar if you looked at today's program. Samir, he is giving a talk right now. up in the fancy room in our new building. If you haven't been there, make sure to check it out. Speaker Hall, it's the best ever location on this Haas campus. But in any case, with this combination of excellent, diverse backgrounds around AI, we are able to cover topics that are more technical, and we try to push the boundaries in how technical you can go. So we do not do ML, as in Python. We do not ask people to do coding, but we try to explain as deeply as possible without having to have some kind of technical degree what neural networks do. And it's a very fine balance, but I think we have mastered finding that balance so that it's not just getting people enough knowledge that they can be dangerous, but they can be dangerous with some level of caution. And then we of course cover more of the managerial topics, but it's many other courses like this either go very technical or very managerial, and it's the balance, I think, that makes the difference. So I probably already described all of these defining design principles. We love defining principles here at Haas, although it seems like we have lost 2 of them. We only have 2 of the 4. If you find them, let me know. The other 2. What are the other 2? Well, you're not supposed to answer that. Okay, you're. I love that. But my favorite one is confidence without attitude. Or is it attitude with a confidence? I always forget. No, that's the other one. So really, it's about this demystification of what AI is, and no technical background. And I like to call this the bridge builders. We try to train these bridge builders. And there should be a lot of focus if you try to use AI in your organization in making sure that the humans in the organizations are not forgotten, because it really comes down to involving those humans, whether those are the employees who work together with AI, or those are the employees who develop the AI, or those are the humans who are your customers. In terms of the learning objectives, we kind of go through a fairly straightforward path from trying to convey what AI can do, focusing a lot on data, and I'll explain that in a little bit more detail when I talk about the financial services examples. And we kind of take them towards implementation, and also we will not forget about the risks. And I'll cover pretty much many of these topics with concrete examples. So that's kind of the goal of the second half, once the sales pitch ends, is to kind of tell you how I think about probably the most important pieces of the puzzle when you try to use AI. With that, I'll hand back to Liz a little bit. A little bit of context, actually, is that so this is an open program. Anyone can sign up, and it has been crazy popular in the past couple of months. 700 people in this online course. But what we like to do is go and work with organizations and customize the program. And that has worked out very well. And this one that inspired this entire presentation was a financial services firm. So Liz, can you talk a little bit about how we do that customization?
Sure. Thank you, Zsolt. So in early 2021, a VP of product from a financial services firm gave us a call. And he had a key insight and a business challenge. And his key insight was the global financial services firm had been putting products into market using AI and had been really successful. And there were also a lot of products that were failing. And he was trying to figure out why. Why was this the case? So he started talking to the teams, the product managers, the engineering managers, and the data scientists that were putting the successful products into market. And he saw that they had a common language. They weren't talking past one another. They actually understood the capabilities of AI, the capabilities of the role of data, and what it plays in creating products and services that utilize AI, and also the risks that were involved. And those teams of product managers and engineering managers and data scientists that weren't as successful putting their products into market, that were never making it into market, were those that were talking past one another. So he said to me, I've got this insight, Liz, and I need a partner. I've got a theory, and I need a partner to help us work through this. And my theory is, if I can train my product managers to be able to talk to my data scientists, and they're speaking the same language, we'll be able to put more successful products and services into market utilizing AI. But we don't have those capabilities to train our product managers internally, so can you help? And I should preface and say that this VP of product at a global financial services firm is actually a graduate from our Certificate of Business Excellence program within Berkeley ExecEd. So he was coming back to Haas, and we love that, just like all of you. So I went through this 4-step process with this VP of product. And we said, okay, let me understand your needs a little bit more. Can we customize the course that we already offer that he was aware of? Can we bring Zsolt into the mix to help us figure out how to fine-tune this? And then let's test it. Let's put it into market. We ran a pilot with 75 of his PMs. He got his data scientists involved as well for us to bridge the gap. And we were successful. So what we did in terms of customization is we took 5 of the 8 modules. We gave the organization access to those modules in a sandbox canvas. They could look at everything. They could look at the videos. They could look at the assignments, the knowledge checks. They had access to ask us questions, and we tailored the course for them. And as I said, they also bridged the gap with their data scientists to make sure that we were really speaking their language. Now, because this was a global financial services firm, there are certain elements that they wanted to handle in-house in regards to compliance and risk, and their capstone projects, which they hoped would turn into products they would put into the market. And so they took that element in-house. The program has been wildly successful. We've run this 5 times. There are 500 product managers at this global financial services firm that are now trained in AI. And we're talking about more. So if this story resonates with you, if you think your firm has a challenge like this, whether they're product managers or other leaders within the firm, please get in touch with us. At the end of our session, there's a QR code for you to interact with us directly. You'll hear from my colleague, Liz Cheney-Brown. If this story resonates with you and you're like, well, I just want to sign up for this course that Zsolt offers. He's a funny guy. Those other interesting professors sounded like they would be fantastic to learn from as well. Zsolt's course is being offered in June. It's an 8-week course, and it starts in June. So again, if you click the QR code at the end of our session, you'll get some information about that course. I'll hand things back over to Zsolt for some more interesting information on how AI is revolutionizing business. Thank you.
Well, thanks so much, Liz. And I should highlight that, customizing a course is not easy. I mean, designing is a little bit, requires a little bit of thought as well, but it's more or less straightforward. Customizing is not easy, and that's where Liz comes into the picture. And she does such a tremendous job every time we work with an organization. It's really excellent to be working with her. So with that, sales pitch is over. So let me share a couple of thoughts about AI, and some of the points that I want to make will be illustrated by examples in financial services. Not because financial services is that special, but I think I've encountered a couple of examples that are very educational. So just a quick intro, AI and financial services. Liz shared some stats about AI investments in general, but if you look at financial services specifically, this chart, it just tells the whole story, right? I mean, if you look at this curve and how it went up from 18% to 80% in 2023, it is astounding. And, everybody asks me about generative AI. Like, what percentage of this is generative AI? It's actually 100%. This chart was generated by ChatGPT. Now, it's always interesting to use ChatGPT, not because it gives you funny results, but because they always change something. So what they have recently done is they started, when it thinks that it's something mathematical or numbers, it starts invoking Python. So if you see that little icon, if you click on that thing, you actually can see the Python code that generated this chart. So we're moving from AI to ML now. So this is the Python code, but I did circle the important parts. So essentially what it does is just, there's the numbers, 15, 20, 30, 40, 50, 65, 80, and then it just plots them. But look at the comment. So it actually does comments, so like a good programmer would do. Example data hypothetical values. So this is true generative AI, right? It just makes up things. But again, this is something you wouldn't know, right? I mean, this is the instruction I gave it. This is what it gave me back. So I mean, it sounds believable, and it probably sounds even more believable if it comes from my digital twin here.
The chart illustrates the rate of AI adoption in financial services from 2017 to 2023. It illustrates a steady upward trend, with adoption rates increasing from 15% in 2017 to 80% in 2023. This growth highlights the increasing integration of AI technologies in financial services over recent years.
All right, so I made this about half an hour ago, just so that I can relax a little bit. Actually, you would be surprised by the lip sync part of the technology. That's 4 years old. The sound, so it's my sound. It's pretty good. It doesn't get the accent yet, but it's getting there. It's very easy to make these videos. They're not perfect yet, but actually ExecEd has been asking if we can reduce our cost. Recording those videos is expensive, right? And I don't really enjoy. So when we make these online content, I write a script, which is where the real value is, and it's made up by me, human Gen AI, and not AI, not artificial Gen AI. But I actually, for one video, I did use AI. I had to replace a couple of words. And it's interesting that I could have just recorded it myself, but I didn't have access to the same recording studio, so the sound would have been different. So I actually gave it a sound sample, typed in the 2 words, and I replaced it in the video. So these things are very useful. But the point I'm showing you this thing is that Gen AI is not something that you probably want to use in kind of more hardcore financial applications. Because it makes up things like those numbers. Let's say you're investing, or this is a report on your portfolio. That's probably not a good thing if those are hypothetical example values. So I'm going to cover 4 points with one example for the first 3, and then a couple of examples for the last one. So the points will be about 2 about the data. So one is just about understanding how valuable your data is, and then the second one is how do you actually convert that data to value. Third one is a little bit of switching gears to thinking about a process. How do you integrate into an existing workflow process, and what you need to consider if you use AI for that. And then the last one is something that everybody always talks about, but I want to make sure that we do not forget. So I'll leave you with those cautionary tales, and we'll have Q&A about 15 minutes at the end of the session. All right, so let's jump into it. So understanding the value of your data. So this is the case of alternative data in financial services. If you're in this industry, you're probably very, very familiar with this term. If you're not, you're probably not very familiar. But this is the idea of using interesting, creative data sources for investment. And one of the ideas there is satellite data, but there's like all the location data, credit card data, social media data, and all that. And it has been shown that these can be valuable. But how valuable, right? So this is from a research paper that I have been working on. And funnily enough, my co-author on this is Panos Paratoukas, who is giving a talk in Wells Fargo. He might be talking about the same thing. We should do a video conference. But the idea here is to look at parking lots of retailers. So this is satellite data. And where does AI come into the picture? It's actually not very hardcore AI. So in all of my examples, what I'll try to show you is that most of the, at least in my opinion and what I've seen, most of the applications of AI that are lucrative and successful are not very fancy. They are not the magical AI. So what we do here, or this is a company that collects this data, satellite data, retailer parking lots. And what they do here is they curate a good amount of pictures. So it's not non-trivial to know where all of these retailers are. This is limited to US. And then they take pictures and collect. They don't directly do it, but they work with satellite companies, and then they save the pictures for the specific locations. And the next step is interesting, where this is where AI comes in. They use computer vision to find those cars. So these are the parking lots. What you have there is cars and some trees. And each dot is a car. Now, data quality is an important consideration here. So they actually had a shift in resolution, and the ability to find those cars dramatically improved. I mean, if you look at this with your own eyes, it's actually hard to distinguish between the tree shadows and the cars. All right, but that's what AI does, right? So it's nothing like magical, right? This is something that is technology that has been around for like 10 years now. They did start this about 10 years ago. And by the way, I think the original application of this type of satellite data is for oil tanks. It's even simpler there, what you need to do with computer vision. The idea is that these oil tanks have floating tops. So looking at the shadow, how much shadow is, you can tell how low or high the tank is, how much oil, so you can get an idea about activity. But back to parking lots. So this is a company called RS Metrics. There's another one called Orbital Insights, so there's some competition there. So they have this product. It's called the Traffic Signals product. So it's pretty much all retail parking lots, and they tell you what percentage of that parking lot is filled. And it's almost daily. Satellites have their limits, even SpaceX. Even Elon Musk, those satellites, that's why he has to send up so many. It's because a single satellite that is in this low Earth orbit that goes like every hour, it makes an orbit. At a given location, it does it the same time of the day, local time. So all these pictures are actually around 11 a.m. to 12 p.m. in the US. So it's not perfect data, right? Because if you want to have an idea about number of shoppers in a store, you probably don't want to just look at 11 a.m. to 12 p.m. But that's what they got. And even this is very valuable because it has a very good coverage. So this is the amount of parking lots covered per state. So very, very extensive coverage. So really what the value comes from is kind of selecting the areas that you should look at, aggregating, processing, and doing this all at scale. So I made a little calculation. Would this be possible to do without AI? And it would. You can just hire someone and go and count the cars. In fact, Sam Walton was famous for being a pilot, a private pilot, and he flew over his stores and he looked at the activity in the parking lots, and that's how he knew whether there is a lot of sales going on. So again, AI is very valuable here, but is it instrumental? Probably not, and that's the case in most of the applications. Now, the interesting part is how do you know the value of this data? So this is just an example of one stock, JCPenney, very successful stock. If you define success in a way of going downwards, But joking aside, the point is that if you look at the green line, which is the stock, and compared with the black line, which is the change in what percentage of the parking lot is filled up, then they seem to be very correlated. Now, if this was not a university, this would be the evidence, but at a university, this is a sample of one, so meaningless on its own. But how do we tell the value of this data set? Well, we actually got access to this data. Now, the big regret I have is that we didn't get real-time access. We got historical access. I probably wouldn't be here, or maybe I would be sitting there and not presenting. But the idea is that we pretend that we had the data and then figure out how much value it could have provided. Now, there is some important context, financial context that you have to know for understanding how this data is valuable. So the idea is very simple. The number of cars in the parking lot gives you an indication of how well that store is doing. And of course, the store already knows that, right? Because they have cash register data and all that. But who doesn't know that is the investors. The investors only find out once a quarter during the earnings announcement. So what we do here is we look at the earnings announcement date, and that's day 0. So that's when everybody finds out how all these stores are doing. But the beauty of this parking lot data is that it gives you, it kind of forecasts what already happened. So it gives you real-time information, real-time insight into something that you will only find out once a quarter. So it's actually called nowcasting, because you're not forecasting something, but you are finding out what's happening now before others. So what we did here is, again, very simple. We just constructed, we split up all the retailers, it's about 50 retailers in top 20%, bottom 20%, and then looked at what happened to those stock prices at earnings announcement. So the top 20% is the green, and the bottom 20% is the red. And what you can see is a huge jump up and down for these two. So if your parking lot is doing very well, your stock price will go up. If your parking lot is not doing very well, your stock price will go down by a lot. So if you combine these into a portfolio, you can actually make 5% every quarter. So that's how valuable this data is. But nobody knew, right? So RS Metrics, they could have just invested themselves. Instead, they started selling a subscription. But the difficulty here was that they just did not know, and they were not confident enough for it. They couldn't get investors who were confident enough in the value of this data. And the bad news about this is that it took us about a 7-year period of data to be able to prove this. And as you can imagine, if you're selling this data to hedge funds, at some point, everybody will use it. So the value actually goes away. So by the time you know how valuable your data is with the AI processing, it will not be valuable anymore. So it's kind of the impossibility sometimes of figuring out the value of something really valuable. So the business model of RS Metrics was here to charge a subscription price. And I mean, they did okay, but not spectacularly. It's like $100,000 per month per hedge fund. So you can imagine with the right amount of capital, making 5% every quarter would have resulted in higher returns than that. Right, moving on to another example. Just about, again, more on the value of the data and how you convert that into actual monetary value. So this is an example where you have data, but you might not have enough data, or you might not have the right data. So this is a very seemingly boring AI application. So I work with a startup that does analytics projects for certain companies, a lot of telcos and retail, but also banks. So the next two examples are from this startup. So the project was simple and fascinating at the same time. So this is a small bank in Malaysia. I cannot tell you which one, but what they have here is a lot of data on these terminals. So these are, the payment terminals. We have the same thing in the US, but there's a lot more in Southeast Asia and very small transactions, but a lot of data. Now, of course, the problem is that if you are not the one that is managing that POS terminal, like here in the US, you would have Chase's offering. It's a lot of small businesses have Chase, but if they don't like that it's too expensive, they get something else. So this bank had only a small percentage of all the terminals. So they had a good amount of data on their own terminals, but they had limited amount of data on the other terminals. Of course, they saw the purchases if it was some kind of card or account associated with their bank. So the problem was that they had all this data on terminals, but only a small percentage of that data was rich enough for it to be useful for anything. So only 2% had the location information. And it's only from our perspective. So it's a little bit asymmetric information like in the other example as well. So the question they had is, can we use AI to predict where these terminals are? And if you are some sort of a privacy-concerned citizen, then the exact same technology should make you very concerned, because the idea here is that we can easily enrich in this data. In fact, the origins of this technology and projects come from telco, where there's a lot of prepaid in Southeast Asia, and prepaid customers are not very forthcoming for a good reason about their personal details. But in a telephone network, if you know who calls who, you can tell just in a small percentage of demographic information. You can figure out the demographics for everybody else. Same idea here. So it actually gets creative, and the specialty of this startup is doing graph analytics. And you can turn everything into a graph, even if it's not required, but here it's very useful. So what do I mean by a graph or a network? So a graph or a network is basically just a bunch of nodes connected by links. But the fascinating part comes from how you build this graph from this type of data. So it turns out, the easy part is that each terminal is a node, and it has all these properties like the size, number of transactions, the category, the location. And as you can already see, most of it is purple, so you don't know the location. But the interesting part is how you connect them. How do you discover relationships between these nodes? And that's where the graphs come into the picture. So you actually connect them based on transactions. So the transactions create these links, these edges. And you can use a lot of things. You can use the amount of transactions. But the key here is that you use transactions by the same customer. Right? So if I make a purchase here, I make a purchase here 10 minutes later, that kind of tells you that those two locations are pretty close to each other. It also tells you something about the categories and so on. So this is just a manual examination of a completely unknown node. I'm not going to go through details, but you can make these observations. Like, oh, these might be close to each other. Maybe the categories match. And then you can actually just go on Google Maps and find potential candidates, right? So you could do this manually, but there's like 10,000 terminals. So again, what is AI? Artificial intelligence. It's artificially doing something intelligent, basically doing something with a machine that a human could do, but much faster and much cheaper. And that's exactly what's going on here. So you take all this information, and then you create these relations based on the transactions, and then you use so-called graph neural networks, or graph convolutional neural networks, which is a fairly novel but already established type of machine learning, neural network-based machine learning technology. And then you're able to predict a lot of things about these networks, about these terminals. So it created a lot of extra value, or basically made this data set valuable, because you can see the numbers there. 10,000 known terminals and 8.4 thousand terminals were then successfully predicted or projected, whatever you want to call it. Interesting part about kind of the the practical nature of these projects is for the top 250, they actually went through them manually, right? 250 is not that huge of a number. So that gave some credibility to the project. For the rest, they did random sampling. And they also made sure that the biggest ones were fully accurate. So a lot of human tinkering went into this. And that happens all the time. So that's one of the big takeaways in our AI classes is that it's never just you take AI and it does it for you. It's you carefully think about how to implement things, and then some things might be easier to do manually. And in this case, the checking at the end for the most important ones was done manually. So that's just the list and locations. Real data, but I'm not going to show you the private details there. So what we have seen so far is, really the importance of data. And oftentimes what you get is that you have a lot of data, but it's not the data that you need. And often you actually have to put extra effort in enriching the data or getting more data. I mean, you can go overboard with this. If you have heard the term synthetic data, I actually have a paper on using AI for market research, using language models for market research. So it turns out that if you ask GPT to act as a consumer and ask them about perceptions about cars, it does pretty well, right? So there is up to some limit, you can generate synthetic consumers, but like half of the market research industry freaked out, like, oh, synthetic data, this is like all a scam, you're just making up things. But really, it comes down to like where you draw the line, and using AI to enrich your data can be extremely valuable if you know where to stop and not just make up things completely from scratch. All right, moving on to, and again, moving a little bit of a different topic, process. So the process is where you might end up doing something very, very simple just to make sure that you fit into that application's workflow needs. So this is an example of a company that does, if you have any international financial experience personally, you probably have run into the trouble of trying to transfer money to a different country, different currency. I sometimes run into this trying to convert to Hungarian currency, which Hungary does not have the euro yet, so it's it's a fairly niche currency. It's hard to get good rates on it, and the banks never even tell you what the rates are. You just transfer it and then hope that they don't take 30%. They only take 5%, right? Now, there are all these companies that try to take advantage of these inefficiencies, and usually you're able to do currency exchange but at 1% cost. And this is one in Asia. And of course, regulators are always on the watch out for money laundering, so there's the need for detecting fraud. So very simple problem. You need to monitor these transactions. But there's a lot of practical difficulties. One of the things is that sometimes the regulation is very clear, like you can't transfer money to North Korea, for example. That's an actual rule that they have. I don't know, maybe people try, but that's a very clear rule. But a lot of the other rules are kind of soft rules, so they just require reporting of any suspicious activities. Like in the US, you have that, right? So you might not know, but many of your transactions could be flagged suspicious by the bank and reported to the government, and then they decide whether they will want to investigate further. So it's kind of those soft rules that are trickier here. Is like, how do we create a system that creates rules like that, but without too much pain for the customer? And pain here means a false positive, right? A false positive means that you are flagged, and then you have to go through certain manual actions to complete that transfer. So this is how the process looked like before, and then it was kind of all done manually or just very, very basic automation. And the new process is like that. So that's the startup links analytics there. And they essentially created this first level flagging. But then the actual company, which we call XYZ here, they still do their second level monitoring, right? So how do you create an algorithm here that is properly built for this particular process, right? Because fraud detection, it has a very kind of long literature. There's all these, very, very sophisticated techniques. I just read an article about MasterCard using generative AI to do fraud detection. Well, if you read the article, it's actually not generative AI, but at least it's AI. They use transformers, but not in a generative way. So you could do this in very fancy ways, but in this case, it turned out to be that the best way to go about it is a very simple way. So they actually just used simple clustering, and that was the way to go. It was a kind of a short timeline and very simple project. So what they did is they just clustered customers, they just clustered transactions based on historical data, and then they flagged all transactions that were not within a given number of standard deviations from that cluster's center. So as simple as it gets. But it was perfect because they could easily adapt to the process, which was, there's the second level of screening. You have to incorporate the feedback. It was very easy to do that. And they could also very, very directly control the amount of positives and so the false positives. And they also had limitations on what data that they had access to. So this is just to show you that with one single variable, you can figure out how much of a positive flag rate you want. So this is the x is simply x times the standard deviation. So if you do 2 times the standard deviation from cluster center, 48% of customers are flagged and 6% of transactions. But they went more for like 8 or 10 when it's kind of more of a manageable rate and doesn't completely mess up your customer's experience. So there's some interesting challenges I want you to let you know about because when you read about AI applications, it's always the magic, the fanciness and whatnot, but bringing it down to earth is very important, and to see these challenges, which are, some of them are ridiculous, like the number 2 point here is no true positives were given. So this was a project on fraud detection without seeing a single example of a fraud case, right? And sometimes that's just part of the process, that you have to develop something without seeing an example. So that rules out all kinds of supervised learning where you have to have labeled examples of positives and negatives. So unsupervised learning is what they were left with. And other interesting challenges is that kind of really a lot of the thinking went into maintaining this balance between kind of like how hard it is to double check, what is the capacity to do the manual checking and all that, and the false positives. If everything is a false positive, then the humans who are doing the second level will start ignoring it after a while. And then finally, this probably applies to any project, but most of the time when you deal with a product which is not inherently very sophisticated on the machine learning front, it is not easy to explain what's happening. And that was another reason that they wanted to go with kind of simple machine learning. If you do a neural network, you immediately give up the ability to do interpretable features, right? So a lot of times people talk about decision trees and how they are highly outperformed by neural networks, and they are, but decision trees give you very, very clear reasons for what they're doing. And similarly here, it's very easy to explain what it means that this transaction is an outlier, essentially. I wanted to give you the timeline in case you haven't seen a real project. It's always very interesting for our students. That's always what they ask is like, how long does this take? So it's about, 5 months total. Just all the steps laid out. So it takes time, even for something simple like this. If you want to do more complicated, it would be easily up to a year. And again, a lot of it is just understanding the data and making sure that the data is either already to some extent clear, or you have to clean it yourself if it's not already in a format or in a quality that's sufficient for your AI application. All right, so that was my third point here is the process. Is like, you could always go for something fancy, but overkill is the enemy of the successful AI application. So you really want to think about that process and how you fit into those workflows and how you fit into not the existing workflows, but how much can you change those workflows and how will you fit into those modified workflows. And that has to be part of your thinking, and maybe it's most of your thinking is thinking about the workflows and not even thinking about the AI part of it. Right, so we'll switch gears a little bit again. So these are a bunch of examples around risks of AI. And the three areas I list here, it's probably not exhaustive, actually three, because fairness bias, those are just two different words for the same thing, and then privacy and security, or you can connect those into one and call it protection, data protection. So one of the common ways that you could make a language model more customized is by making your own from scratch. Now, this is actually very hard to do, but sometimes it's necessary if you want a good enough quality conversational AI. And Bloomberg did this fairly early on in collaboration with the universities, so they didn't do this on their own. They created a large language model for finance, specifically trained on financial data. And you would imagine that if you are a bank, for example, and you want some kind of a customer service automation, you would want to make sure that it's not ChatGPT, right? You would want to have full control over what the model does, and you would want to have very relevant training data for that model. So this is just an example from a bank. They would kind of explain what's in your statement and whatnot. And usually the way this is done is that there's automation. Some of these responses are automated, but at some point a human takes over. Now, what I want to illustrate is the danger of full automation, even if it's limited to very small pieces of the customer experience. So this was a pretty big scandal a couple of years ago. And, in the hindsight, it's kind of easy to avoid. But at the time, this was 3 years ago, so not that long ago, this was fairly innovative. So this was actually Capital One. What they did is, how do I improve customer experience for a credit card customer? Well, all those cryptic notes for transactions, why not try to turn them into something humanly readable? So what they did here is they had a transaction from AA.com and used some kind of language model to expand on what AA means. And the language model happened to describe that as African American service charge, which is really problematic, but it really should have just said American Airlines, right? So people really got upset, and really, you can go into your language model or an AI tool, and you should make sure it doesn't do that. But it's impossible to prevent all problems, right? You cannot think of everything that could possibly go wrong. So really, the danger is from the automation, is from the lack of human oversight. So it's kind of a combination, finding the balance between like how much can I do to make my model safe versus how much am I willing to expose customers to fully automated results. So it's another example, insurance. this is about fairness. So how do you do fairness with these algorithmic decision tools? So the algorithm, what it does here, it sets the car insurance rates, right? So it analyzes your data, and then it spits out a number, your risk, and that is your price you pay for car insurance. So what the car insurance industry does, it relies very heavily on information like credit history, occupation, employment status. These are different types of data points that different states allow you to use. California is an exception there, but most other states allow you to use pretty much anything you want. So this company is called Loop. What they do is they came out and they said this is unfair. Credit scores are very biased, and we will not use credit scores. What we will use is we'll use actual traffic and location data. So they essentially try to predict each customer where they will go, where they will drive, and compare that with traffic data and accident data. And that's kind of a direct indicator of the risk for that customer. Now, of course, a lot of insurance companies try now to track you once you're a customer, but the difficulty is if you are a new customer, we don't know anything about you. So what they do here is try to forecast the risk for unfamiliar customers. And it's kind of a nice idea, but and it makes sense to say that, well, credit score might be somehow correlated with driving risk, but it has nothing to do with driving. So it's an unfair predictor, even if it's correlated. And this is much more directly related to the risk. But again, you can make arguments that this is unfair because it's not that you can freely choose where you live, and you might live in an area that has higher accidents, and you might have to drive to areas to work that has higher accident rates. So it's it's probably more fair, but it's not the ultimate fairness level here. But it's an interesting attempt. So again, when you think about these financial products or insurance products, it's important to think about what variables, what data goes into it. And I have a chart on credit scores just to illustrate why it could be unfair, and whether it's unfair depends on the definition of fairness. And it comes down to how you look at it. So it turns out if you think about credit scores, the purpose is to predict whether people will repay the loans. So the one on the left actually shows you that if you look at that by race and by credit score, it's a calibrated predictor, which means that given your credit score, the percentage, the probability that you repay your loan is actually not dependent on your race. But if you just look at the pure distribution of credit scores, you can see there's huge differences in credit scores for different races, right? So if you're really going for that particular objective of predicting loan repayment, then sure, you could argue that maybe that's fair to some extent. But if you're using credit score for something totally different that has no direct relationship to repaying a loan, then it could introduce a big unfairness into your algorithm. And this is just one variable, right? There's tons of variables that go into these. One of the other contentious variables, by the way, for this insurance company was marital status. Marital status happens to be very correlated with driving risk, but is it fair to use it? Is it unfair to use it? We know that there is differences between different groups, so that is an interesting question there. Credit and lending decisions are, at the heart of this problem. And here you might argue that credit score is okay to use because it directly measures it. But there's this big scandal about Apple Card. It was accused of being sexist. And it basically came from a number of reports where spouses both applied, and the men got much higher credit limits. A couple of reports, they got investigated. After 2 years, they found that all the decisions, all the specific examples were reasonable. It basically came down to that even though, and the argument they made here is that we live in a community property state, so we have the exact same properties, right? Because we co-own everything. But it came down to, the investigation came down to, they went into details, they looked at what was the actual variable responsible, and they discovered that it was actual history of different cards, which are separate. Now, is that fair? Is that not fair? We don't know, but the big problem here was lack of transparency. These people who reported these things called Apple, and we don't know, we can't tell you. The investigation is like a 100-page report. They got the data, and then you can have a discussion whether it's fair or not fair, but you have to be extremely clear with your communication. Just my concluding example is one where a company did get into trouble for unclear communication. So this was Lemonade. It's going back to fraud a little bit, and insurance. So Lemonade is about automating fraud detection and insurance claims. And they put out this tweet. It's like, oh, we use all these videos and we use AI to look for examples of fraud. And then people got really upset, partly because emotion detection and lie detection is extremely unreliable, and also because it's very prone to bias between different races. It's actually so unreliable that the EU, in their AI Act, they banned all kinds of emotion detection tools with AI. So you have to be extremely transparent, but careful about what you say. The irony of this story is that this is going back to putting back my marketing hat on. This person who wrote this tweet made it up. They did not use it. She made up that they used emotion detection. They did not really use it, so it was just trying to be a marketing gimmick, but it did backfire quite a bit. So lots of fraud, but I'll skip the fraud examples in the interest of having time for questions. You can imagine fraud. I mean, the funniest example is that call in Hong Kong where there's like 10 people on the call and one real person, and the 10 deepfake AI Zoom participants made that one real person transfer $25 million. Not a good day for that one real person. Good day for the 10 artificial people in there. But always watch out for these risks, and never forget to kind of foresee and try to anticipate them. All right, as Liz promised, there's a call to action slide. So anything to say about it before we go to questions?
Yeah, just briefly. If you would like to get access to the slides today that Zsolt stepped through, those are some fascinating examples from Zsolt. Click this QR code, and you will also get access to marketing emails from Berkeley Executive Education, and the ability to learn more about Zsolt's AI course and how to customize it for your organization. But this is the way to get in touch with us. And again, have access to today's slides. You can retell those fascinating stories in your own organizations, as well as keep in touch with us. And we've got time for questions. So Zsolt, I'll hand it over to you for Q&A.
Sounds like a good deal. You get spam completely for free. All right. Question there. Microphone is coming.
Yeah, so this is a very specific tactical question about that orbital insight use case.
Yeah.
So it goes back to the whole correlation, not equal to causation, and how in real world it's a multivariate problem, and you spend all this time and energy just refining one variable. In that, well, target parking lots are empty because COVID's going on, or because everybody is buying a bunch of stuff online, right? So to say, well, parking lots are empty in physical stores, therefore Target stock price will go down. That's where I feel like the suits lose the hoodies, so to say. So I mean, there are many real world examples of this, right? So I don't know, so where do you think that conversation's going?
Oh, great point. So that's one of the difficulties with computer scientists taking over the world, because they care more about just that it works than there is causation. And this is a little bit of a philosophical discussion, whether Does it matter if there is causation, if there's correlation that makes you able to predict something? But when it starts mattering, is exactly your example, is when something changes, right? So if something that works, it's fine, it works well, but something dramatic happens, then if there's no causation, then there is kind of no results going forward. Now, just to be fair to the computer scientist, what's the alternative? Is you come up with a causal model. Now, in the particular example of COVID, wouldn't have helped because there's just no data that could have helped us understand what are the causal relationships during a pandemic that really never happened before in kind of the modern society way. So good point, but I agree with the sentiment that kind of the overall industry is moving a little bit away from the causation just because of focus on performance that could cause issues. All right.
Hi, thank you very much. Speaking of computer scientists, what is your view on the current state of the job market for AI and machine learning engineers? And how do you see it going forward with the advent of technologies like Copilot and other things related to AI?
Yeah, so it's very volatile. I mean, I'm hearing a lot of positives for the AI experts. Like Peter was complaining that some of his PhD students get $10 million packages at OpenAI. But again, it's volatile. It could change. Now, if you ask me about Copilot taking over software engineers, I'm skeptical about that, right? So it might be bad news for the very kind of low end of software engineers. And these would be people who, were truck drivers and decided to go into computer programming, and they were able to do that because humans are very good, brains are very good. But if they learn for a year, they can do something very simple. That's where kind of the co-pilots are. I did ask. Actually, I have a friend who worked on one of these projects. Actually, he used to be at Google. He's a kind of, I would say, highly sophisticated engineer. I asked him, so are you worried about these things? Like, his answer was that, me personally, I would not ever want to write code which is similar to what AI can write. So his point was that kind of the amount of thinking that goes into making the code elegant and simple enough is where value really is, and AI cannot do that now and in the next, 10 years. More than 10 years, don't ask me about it. My crystal ball in my office is limited to 10 years. Who is next? Oh.
Hi, Zsolt. I was in your class a few years ago, marketing.
Fantastic.
My question is on just application of AI and generative AI and going forward, like similar to what you showed about Target and Walmart and parking lots. If as we apply more AI and generative AI, do you expect that there will be some kind of diminishing returns, even for coding, other AI use cases?
Yeah, so I'm actually working on a project about creative AI. It's a very interesting area. And I guess to some extent it applies to coding as well. If you think about the value being the creativity, and it's unclear where it will go. I mean, there's one possible outcome where what AI can do is better than what the best human can do. Well, in that case, we can just go to the beach and have fun, right? But that's probably not the case. The best humans will be able to do better than what AI can do, and then it comes down to a lot of the practical details, like what is the distribution, like how much can the best human exceed the second best human? What are the distributions? Because AI is consistent, it's very easy to use, very cheap to use, and there are scenarios. At least that's what they're finding, is that the best humans may actually even benefit. They might be more highly sought after than currently. So that's probably what I would predict for the next 10 years, maybe 11. It will have an impact on the lower tiers, but it's a little bit like online education, online classes and universities. we are benefiting from it, right? We are definitely benefiting from it. There's, what is it, University of Phoenix, the school where my daughter might go, they are just taking over a campus from a university. It's called JFK University. It's one of those very low tier. They went out of business. I see it similarly. So the best of the humans will actually possibly benefit. But the big question is, and that's the big question for society, is it the top 1%? Is it the top 50%? Is it the top 75%? Which I don't know. Even my crystal ball doesn't know that. I don't know the order. I'm sorry. So whoever gets a grab of the microphone.
Good to be back in your class. I was in your CTO program last year. On the target parking lot application, but we discussed a variation of it on the macro level of how the night lights determine the economic activity of some companies and how the rates can be inflated. But now it looks like with massive data available, it's getting down to individual company predictions.
Yeah, that's the origins. And that goes back to the 80s, 90s, just looking at lights. But again, the difference between that and this one is the AI. You don't need any kind of machine learning to look at lights in a picture. What you need to find cars, right? It's a small difference, but that is what really creates the value. And the other difference is actually the curation of the images. Because those macro studies that look at night lights, they just look at the entire continent and countries. So those are the small things that make the big difference. Do you have a mic? All right. Can you do the yelling a little bit more?
Yeah, the demand for electricity in this country is going to go up like 20% electrification in general. AI is a big part. How do you basically see it? When you talk about AI, I'm thinking about sustainability and electricity. How do you produce a system? Well, it's two things. Where's the power going to come from? That's the way. But realistically, it's going to be gas and fossil fuels. AI is going to have to play the blowing of it. And how do you basically use AI in a way that's environmentally responsible for self?
Yeah, so you might have to pick between driving a Tesla and using ChatGPT. But I think you're asking about electricity and how AI and the current advancements can basically be satisfied, the electricity needs for it. So Elon Musk, I hear, is interested in buying some company making transformers. It's not even at this point in the maybe next, what period do I want to use, 10 years maybe? It's not even about just the amount of electricity generated, but just the infrastructure of getting it to the right place. So building data centers with electricity generation on the spot. But there's these charts trying to predict the medium term, basically limits to what AI can do. And it compares the amount of compute needed for basically the state-of-the-art models. And it's actually, it's worse than just linearly increasing. There's always, like, whenever they invent something like transformers and deep learning, the slope goes up. So to get the most out of AI, we need a lot of compute. And part of the problem is electricity. But the other part is just the sheer amount of hardware. So combination, and I don't know which limit we'll hit first, but only in a couple of years, some estimates show that the amount of hardware that's required to run these best models, the best of the future models, is going to exceed, the cost of that hardware is going to exceed US GDP. So obviously it's unsustainable, whether it's energy or hardware costs or whatever, but we are going to hit a ceiling unless something dramatic happens in discovering a much more efficient algorithm or much more efficient hardware. And Sam Altman just wanted to invest $7 trillion into hardware.
This will be our last question.
All right, last question.
Okay, thank you. Awesome presentation. I think to the gentleman who asked the last question, I would say, take a look at a company called Vivum Computing. They're doing something interesting in what that is happening. two things. One is an idea for that insurance company. Maybe they should track for risk whether you're driving with your spouse or not. I think that'll be a better tracking mechanism. But question on the timing. You said a simple project takes about 5 months. Have you found yourself in a situation with a client where they have unrealistic expectations, where they expect that stuff to get done in a month or two? How do you deal with that? I mean, I think there are a lot of people who think a lot of this stuff can be done very quickly. In reality, it does take a set amount of time, and I'm interested in how you handle that situation when you come across that.
I mean, it's easy. You just tell them that it's going to take 3 times as long as they expect in the very beginning, right? If you know that, yeah, I mean, but then you can be the "I told you so" person, right? So the key is to always have realistic expectations on your part about how long it will take, and then you're fine. The trouble starts when it's kind of the first or second project for you and you have no idea. And then the unrealistic expectations come from all sides. So just like overestimate, and then that solves the problem. I can hear that, but... Oh, the timeline? No, mostly because of the data. I think the only way it will change if companies really figure out how to kind of organize their data in a much cleaner fashion. And that will happen. I think that will basically cut everything in half because that first half of just data cleaning will go away. And that depends on, if you work with a very sophisticated tech company, that part is not there. But kind of most of the more traditional companies would have to deal with that, and it will take a long time for them to figure that out. All right, I think it really was the last question. Thank you so much.